Alright, let's design a sort of a matte foundation right in STAAD Foundation Advanced Connect Edition here. Okay, first let's draw some columns here. Just get a room for this. Alright, right in 0, 0, 0, sorry, 0, 0, 0. Alright, one column is right at the origin. Alright, okay, then I like to pick up the size of the column. It could be like maybe 0.5, so I'm gonna change up everything right into 0.5. So all of these columns having a size of 0.5. Alright, then let's assign some sort of load right into here. Assigning a sort of dead load right here. So adding the load, applying a column reaction load of maybe minus 500 kilonewton, add it and just assign this acid right into the old support here. That's it. Then get into load setup. Okay, this one could be a mat. From a mat foundation, I'm gonna do something for India. Assign systems and assign the old support here. Okay. Alright, maybe I would like to apply a combination right here. So get him here, pick up the code. Okay, of one for service and the other ones for ultimate. Alright, that looks so cool. Just get into job setup and pick up a name. I'm gonna design a mat foundation for mat. Code is following Indian standards. Okay, like to pick up all the load cases and create a job. Wow, that's okay. First case in mat foundation is we need to assign a sort of mat right into here. So first I get into default properties. I like to assign the thickness for slab as a 500 millimeter. So slab design thickness, first one is slab analysis thickness, which will be used in the analysis of a slab, and this one is used for the design of slab. Subgrade modulus, it could be maybe like 24,000. Again, how the soils grade having the unit density of 30. The concrete density that I have provided is 25 here. Alright, there is nothing more. I'm not going to have the beam section properties. I'm assuming that there is no beam connecting all these columns here. There will be, but in this tutorial I'm not designing that asset here. Okay, if you're having some sort of beams here, get into physical beam table, and I'm saying that node 1 to node 3 having a sort of beam depth and width. The size of the beam could be given here. Beneath, if there is sort of pile of the mat is supported on pile, I can enter the pile properties right here. I'm not getting into that. Adding the meshing region. Alright, I'm getting to the rectangular meshing region, and I like to convey the x coordinate right at the top left point. It shall be negative 0.5, and the z coordinate shall be negative 0.5, and the length and width shall be 6 meter, and name the region and add the region. So we got the mesh right to the perimeter of the column right here. So if you might not understood what have I done here, it's a simple thing. As you analyze this figure, the size of the column shall be 0.5 and 0.5. The spacing between the columns are, the column is 5 meters, so the total horizontal distance will be 0.5 plus 5 plus 0.5, it could be 6 meter. Okay, in the top left coordinate, the shall be origin shall be right here, and this one is 0.5 and this one is 0.5, so that's why negative 0.5 is here and 6 both here. Right after getting to meshing setup, and I like to add the meshing region, it's just 0, 1, and generate mesh weather. Alright, okay, just select the mesh, select the region, then I like to generate the mesh. What sort of meshing do you want? Alright, I need quadrilateral meshing right here, so you can see quad meshes right here. Getting to slab thickness, we had already provided the number here. Soil properties, this is cool. If you don't know what's a sort of subgrade mollusk, you can calculate from the bearing capacity by using this formula. Okay, then pile spring. I'm not assigning any sort of pile spring here. Finally, analyze the structure. If I'll ask you to save the asset right there and wait for a couple of time. Alright, I'm trying to decrease the I'll try to increase the thickness of the slab right into 600mm, so I got lesser stress in concrete. So I'm supposed to use some stress which will be bearing right. So I'm supposed to use M25 or M30 here, so that's okay. Now I can see soil pressure. Again, how the soil pressure, the numbers 0.112 will be always greater than the safe bearing capacity of the soil. We design slab right here, so just get into slab designer, pick up all the parameters right here, and you can go for result summary. Alright, you got area of steel for 4 parts here, so got longitudinal top, you got longitudinal bottom, transverse top, and transverse bottom here. Okay, I got detail report here, not getting into it. You get how transverse reinforcement, the moment and the equivalent area of steel is provided here. It's 720mm square per meter. Okay, so I don't want to print anything, I'm sorry. Right, then I'm having zoning right here. Basically, I'm in the zone 3, so I'm gonna like to see the zone report first. Okay, most of the properties are found right in zone 3, where the size is 10 of 50 center to center spacing, which is very congested. There won't be anything for zone 1 and 2, so we got zone 50s and a lot of other zones are here. Alright, so zoning is basically, the STAAD Foundation will group, right, the reinforcement zoning, reinforcement into a particular zone as the low moment zone, high moment zone, and all. So the zoning is something like that. Alright, create a zone report right in the zone 3. I got something like this. Alright, okay, so assume that this one's showing up. The spacing 10m50 spacing, those points are visible right here. Right, then I can have the moment capacity check. Alright, then finally calculation sheet right here shows all these properties related to our asset. So that's all about